Hello all, welcome to the video lecture series for the subject compiler design. Now I am going to explain you all about DAG, that is a directed acyclic graph. Basically here this optimization technique, how does it works with n number of other processes which have provided an excellent way of optimizing any given expression, any given input, any given source process, right? So here we are going to see the different way of technique. How does the directed acyclic graph which helps in optimization, right? So let me take you to the process directly, right? Now basically this structure of a basic block will be optimized, so it is used to represent the structure of a basic block. Okay, right. So what is the purpose of it? It is used to visualize the flow of values between the blocks, right? Here you can see it is representing a structure as well as it is usually visualizing the flow of values between the blocks, right? So here it is always used to optimize the technique, right? That is the purpose for the reason which provides optimization technique in basic block, right? And also DAG is a 3-address representation of code which is generated as a result as an intermediate code generation, which is always facilitates the transformation of basic block, right? So the basic approach here in directed acyclic graph, it is always focused towards optimizing a 3-address code, right? So let me take you with a basic example where you can identify how does the expression works on that, right? So here you can see that the first expression, right, t0 is equal to a plus b. Got it? Yeah, t1 is equal to t0 plus c, and finally d is equal to t0 plus t1, right? So here you can see that this is the one basic expression we have taken. All of this expression will have a dependency of other process. Say for example, I am starting with this t0, right? So t0 is equal to a plus b. So I am going to have one expression and then later depends on the others, right? Now the value, whichever the value have a resultant, that will be in the top. So example, it is t0, right? Now we have this plus between this a as well as b. So how to read, how exactly it is going to generate? t0 is equal to a plus b, right? The expression number 1 has been completed. Let me take it to the expression number 2. t0 is equal to, t1 is equal to t0, the previous result value, plus c, the new value. So we have already got this t0 here. So the only thing what we are going to do here it is, we are going to have this particular process, right? So it travels towards this direction. Now t1 is equal to t0 plus c. This is how it works, right? Now we are going to show that how exactly this minimized approach has been adopted. Okay, now we have a final expression. This expression is also over. We have a final expression that we are going to take t0 and t1 together, which is saved in the resultant value called d. So the final approach can be drawn in this direction. So here I will draw it. I'm going to have this plus here because t0 plus t1, right? The resultant value is d, so I am putting in this way, right? So t1 is here, t0 is here. So let me take to this t0 first, and then I am going to add this t1. So d is equal to t0 plus t1. So always whatever the direction it flows, that is very important. Got it? So every direction which focus towards, that will mean exactly in which direction this resultant value is, or else in which direction this values has been stored in. So this is how a basic process can be adopted with n number of inputs, right? So this is the best example I can give you where the directed acyclic graph plays a very important role in optimization technique. Thank you.